Hello class, welcome to homework number 9. So today you're just going to be making flashcards. It's important to actually watch this video because not only am I going to show you the flashcards that you're going to be making, but I'm also going to be explaining it with images that you should really be able to recognize and learn from. So we're going to start with the Big Bang. So on one side, you're going to write the Big Bang. I'd pause the video now, write it down, and then press play. Okay, so formation of the universe, 13.8 billion years ago is when the Big Bang occurred. Pause the video, write this down, now listen up. So this is really the image of the Big Bang that we have over time. So the idea is that this would be the start of time when the Big Bang first occurred, and this is time that goes on, and we are here now. So what you could see is that the Big Bang started as a little point, and it inflated into the universe. And as that inflated, it got bigger and bigger, and now it's continuing to expand and expand. All right? So that's the formation of the universe, which is the Big Bang that occurred 13.8 billion years ago. Here's the next card. Pause the video. Okay, so what you're going to put on the back is the proof of the Big Bang. That's what cosmic background radiation is, and it is evidence for the origin of the universe. Pause the video. Okay, so cosmic background radiation. If you look at this picture of the Big Bang, pretty much what we want to do is imagine that time goes backwards. So the further we look into outer space, the more back in time we're actually seeing, because it takes light time to travel all the way to us. So if we look as far as we can, we'll actually see an image that looks just like this. And this is cosmic background radiation. It's the idea that it's the energy that was first released after the Big Bang. And it's the first thing that was released, which means that it's the furthest thing that we could see. So this is really what the entire universe looks like. And this is a three-dimensional picture, just so you know. Okay. Next card is going to be Redshift. Pause the video. So, what you're going to put on the back is evidence of expanding universe. Redshift proves that the universe is getting bigger and bigger and bigger. All objects move away from other objects. Okay, so pause the video, write that down. All right, so what's that saying? Redshift. Light is just a wave. So when an object moves away from you, that wave pretty much gets stretched out, and it makes it look more red. If an object is moving towards you, the wave gets compressed and it looks a little bit more blue or violet. So we say, it's going to say violet on any of the tests. So the idea is that almost all the galaxies that we see in the universe, these are galaxies, right? That's a galaxy right there, have a red tint to them, or a red shift to them. And that proves to us that the universe is getting bigger and bigger, supporting the idea of the Big Bang. So, two pieces of evidence of the Big Bang: redshift, the universe is expanding, and cosmic background radiation is proof that the universe is 13.8 billion years old and released a bunch of energy. Next slide, work hard. Gravity, pause it, write it. So, gravity attracts mass. So if two things have mass, they're attracted to each other by gravity. And this is how nebulas form into stars. We'll get into that a little later. So write this down, pause it. All right, cool. So nebulas turn into stars, and we're going to learn a little bit more about that. But first off, what affects gravity? Write it down, pause it. And pause the video for this and write it down on the back. So, two things really affect gravity: the distance between two objects and the mass of those objects. So you can see in this image, if two objects have a low mass, they don't have much of a force of gravity towards each other. They do have a force of gravity, but it's not really strong. The greater the mass of the two objects, the more of a force of gravity between the two. So, mass affects gravity, but the other thing that affects gravity is the distance. Take a look at the length of these arrows when they're far apart. That represents the force of gravity. And look at the distance between when they get closer. The force of gravity increases. So, when do you have the most gravity? When you're close to a large object. So, close closeness in proximity, and really, really heavy objects have a lot of gravity. Okay. So, the next card you're going to make is Milky Way Galaxy. Pause the video. Okay, so, write down these two, write down this one slide. Pause the video. Okay, so, the Milky Way Galaxy contains our solar system, which includes the Earth, Moon, Sun, our planets, asteroids, comets, dwarf planets, but it also includes billions of stars. So this is what we believe the Milky Way looks like, something similar to this, maybe not so colorful, probably more white, but it is a spiral galaxy, so you should add that to this. Spiral galaxy. It almost looks like a toilet bowl flushing. And we live on the edge of one of these limbs, one of these branches here of the spiral. Okay? So the main idea there is understanding that the Milky Way Galaxy contains billions of stars and us. All right, almost done. 2 more. Nebula. Write that down. Pause the video. Oops, sorry, 3 more. So nebula. So nebulas are a massive cloud of gas and dust. Stars form inside nebulas. So pause the video. Write that down. All right, so here's an actual picture of a real-life nebula. It literally looks like a giant cloud, but the thing that you've got to understand is that this giant cloud is the size of many, many, many solar systems. So you see the distance between these stars here? That is really, really far. It probably takes, like, I don't know, 10 years for the light to travel from one of these stars to another star. So these nebulas are gigantic, and they're pretty much nurseries for stars. These are where stars form, okay? So that is what a nebula is, and energy from stars. So pause the video. Okay, so anytime you see the word energy and stars, I guarantee the answer on the test will always be nuclear fusion. Okay, so write this down. Pause the video. Okay, nuclear fusion is literally just combining light elements to form heavier elements. And for the most part, like in our sun, it's taking 2 hydrogens and squeezing them under heat and pressure, like tremendous heat and pressure. And that forms a helium atom and a ridiculous amount of energy. So 2 light elements form into heavier elements. That's called nuclear fusion. That's what gives a star its energy. Final one, supernova. Okay, so write it down and then write this down. Pause it. So, a supernova is when a super giant star or a really, really big giant star explodes. I mean, 99% of the time it's going to be a super giant star. I don't even think giant stars go through this process. But this forms either a neutron star from a supergiant, or a ridiculously huge supergiant star would form a black hole. And this is where you could see that process. So the lifespan of a star, it starts with a nebula. It forms either a massive star or an average star, and then they continue to go on. Average stars end up losing their atmosphere and becoming a nebula where more stars can form, and in the center a white dwarf forms. But these massive stars create supergiants, and when supergiants die, they go through this process called supernova, and either makes a neutron star or a black hole. So you really just read along this and you figure out if it's going to be a super giant star, it'll become a black hole, and if it's just a supergiant, it'll become a neutron star. Okay? So you should have these cards with you tomorrow in class, and these are really good for studying.